Hi, my name is Anmol Bajracharya. I work in probability and stats team at Wolfram. Today I'm going to be talking about financial time series processing in Wolfram language. Done. I'll start with an introduction to time series and how to construct financial time series in Wolfram language. And then I will start on how to process time series using the existing functionality available in Wolfram language for time series. If I have time, I will also go through this trading chart and financial indicator function. In Wolfram language, the collection of ordered time value or date value pairs can be represented in time series format or event series or temporal data. In time series, we assume that the observations are in a continuous time and it only allows one path. The values between the timestamps are interpolated by linear interpolation by default. And during the construction of time series, we can also specify the method of interpolation while constructing time series. Event series represents a series of events in discrete time. So we will not be able to interpolate values between timestamps. Sure, sorry. Does this look all right? Okay. Temporal data is similar to time series, but the difference is in temporal data, it allows multiple paths. And there's also one difference, like when you're interpolating in temporal data, the values are going to be held from the left. And the method of interpolation can also be set during the construction of temporal data. Today, I'm not going to talk much about event series and temporal data, but if you guys are interested, you can refer to the documentation. I'll only focus on time series and the related functions, but the techniques of time series processing can be applied to both event series as well as temporal data. Here are the list of options and properties available for time series. I'll mainly focus on resampling method and temporal regularity options, and I'll be using all these properties throughout the slides. This is a very simple example for constructing a time series. Here what we are doing is we have a list of values and we have a list of timestamps. And we feed these two values to time series and we can construct a time series object in Mathematica. After we constructed time series, note that the values are ordered by time. But the thing is, when we had a timestamp, we can see that the timestamps were not ordered. But after construction of time series, it will automatically, or the values are automatically ordered according to time. This is just by design. Yeah. But there are multiple ways you can construct time series, but this is just a simple example that I wanted to show here. So how do we construct financial time series, right? In Mathematica or in Wolfram language, we have financial data function. And we can get a data from using financial data, and it returns a date value pair. So this is a different example of constructing time series. So once we have a list of date value pairs, we can provide this date value pairs to time series, and then we can construct it. And one thing to keep in mind is like when we are downloading a data from a financial data function, it comes into business days. So if we use a default setting of time series function to construct financial time series, then when we check the regularity of the time series, it will return false. This is something that we need to figure out how to resolve it, and I will talk about this in next few slides. And this is a nice date list plot of our financial time series. Sometimes we have to also download the data or load the data from file, right? we will be probably working with a text file of financial data or CSV file. Here I downloaded a historical price of Starbucks from Yahoo Finance, and in order to load the data in Mathematica, we can either use semantic import function or import function. And in this example, I am using semantic import. Once we use semantic import function, it will get the data in a data set form. And we can see the first 5 values of first 5 rows of the data set by just using the part function. So from this data set, now I'm interested on constructing a time series of a closing price. So how do I do this? So I will just extract all the data from this close column here, and then all the data or dates from this date column here. And by using normal function, we can convert the data that we extracted from data set into a list. And once I have the data, a list of dates and closing price, I can construct time series by using time series function. And this is the date list plot. We can use this path length property of time series to count how many data are there in a path. So in my previous examples, I was just using a default settings when I was constructing time series. And I mentioned about an issue where the regularity was not returning true by evaluating regular sample Q. So we have a temporal regularity option in time series, which we can set it to true in order to make the time series regular. But sometimes when we're analyzing financial data, just assuming the regularity of a time series might not be sufficient enough, especially when we are dealing with a daily financial data. So we have to resample it according to the business days, because the data comes in business days. So how do we do that? We have a time series resample function that we can just use it to resample it according to the business days. So here is a simple example of how to resample your time series according to business days. I would also like to introduce another function, time series window, which is very handy when we want to actually zoom in the interesting time intervals of a time series. So here is a simple example of how to use this time series window function in order to zoom in the data. So for instance, in this plot, I'm just interested to look at the data from April to July. So I just constructed this time series window function, provided the time series, and provided the first date and the last date of the range. And here's a nice date list plot. When constructing time series, by default, we have a linear interpolation, right? Sometimes it might not be the right behavior that we want when we are analyzing financial time series. So let's look at this graph. So when we use a linear interpolation, then what would happen to the values when we want to find out if the timestamp is not inside the when we want to inquire about the time when it is not inside the timestamp that we give. So for instance, this red dot represents the first date of time series, and this blue dot represents the last date. So what's happening here is before the first date, the values is decreasing continuously, and after the last date, it is increasing continuously. This might not be something that we want when we are analyzing multiple stocks. So how do we handle this kind of situation? So we can use this function, not function. We can use this resampling method option when we are constructing our time series and set the interpolation order to 0. So once we do that, what's going to happen is it's going to actually hold the values from the left. And here we can see the visualization of those two interpolation methods. In Wolfram language, we have functions like log and ratios. These functions can be directly applied to our time series. And it is very useful to compute like simple returns and log returns. So here I already have the time series for Apple and Amazon. And I simply use this ratios function and log function to compute the simple return and log returns. And this is the visualization of Apple price for log return. And as you can see from this graph, the difference between log returns and simple returns is not that much. But usually in finance, we use log returns for financial modeling. Accumulate is another useful function that can be used in finance for computing cumulative returns. So if we have a log returns, then when we want to find out the cumulative returns of an asset, then we will just be taking the totals of accumulated elements, right? So we can simply apply this accumulate function to log returns. But I would like to mention that when we are using accumulate function, we have to make sure this log returns are regularly sampled. Here I'm commenting this code out, but like you can use financial data function and time series. This is a nice way of constructing a financial time series data, and it has already been resampled. So, but I already have this data over here. In time series, if you want to divide or multiply the values of time series, we can simply just multiply or divide like other operations. So here, what I'm interested in is I want to find out the evolution of a $1 investment in Apple stock and then Amazon. So what I'm doing here is I'm simply dividing the time series of Apple and Amazon by the first value. So this first value is a property that I showed in my previous slides. So this way you can actually get the first value of your time series. So I'm just dividing it. When you visualize it, this is the evolution of $1 invested in Apple and Amazon. We can also divide one time series by another time series. So in this example, what I'm showing is what would be a relative value of investment in Apple compared to Amazon. So if it is so when we divide it, if it is going to be greater than 1, it is saying that Apple is performing better than Amazon in this case. We can also add multiple time series at the same time, and this technique would be very useful when we are computing the portfolio returns of multiple assets. But this is just a very simple example of how to add arbitrary time series objects. In this slide, I'm showing how to use moving map function for computing the moving correlation of two securities. So here I constructed a time series of 2 dimensions, and I applied this correlation function to our time series, and I can get moving correlation function using moving map. And since this this time series is 2-dimensional, if I want to divide this time series into its path component, then I can use a path component properties of a time series, and I can get 2 different time series. So when we are doing analysis with financial data, we would like to figure out or identify the trends of upward and downward trends for price movements, right? So how do we do that? So we have moving averages function and time series thread function in Mathematica or Wolfram language, which we can use, combine it together, and then identify those trends. So in this example, I'm computing moving averages of S&P 500 with a shorter window period and longer window period. So if the values of If the values of shorter window period is going to be greater than longer period, then it will signify that the price is going upward, right? Uh, so now I will generate a signal and buy signal and sell signal, and I will show you how to use time series thread function to do that. So Boolean function basically returns 0 and 1, or 1 or 0 for true and false. I'm using this time series function. I'm defining a function to return 0 and 1. I'm feeding two different time series here. This is a visualization of the signal filter that we just generated. So now what we will do is we will use this signal filter to generate the actual buy and sell signal. So how do we do this? So in order to generate a buy and sell signal from that signal filter, we need to find the successive differences between the values across the path. So we already have a difference function in Mathematica implemented, so we simply apply this difference function to our signal filter, and then we can generate a time series of 1, 0, and -1, where 1 signifies it's a buy signal, and -1 indicates that it is a sell signal. So this is a plot for that. And so now I want to find out the actual dates and actual dates of upward trend and actual dates of downward trend. So I can use a cases function here, and I'll extract those dates. And I put everything together in a nice visualization, which shows price of S&P 500, 2 moving averages, and buy and sell signal. And this is a plot of time series window to zoom in to just like from here to here. Here are other list of time series processing functions. Okay. In Wolfram language, there is we already have implemented about like 100 financial indicator functions. Here are the list of all the indicators that are already available with our language, and this can be used with a trading chart in order to visualize the candlestick chart and the indicator function. So, and here is a simple example. So when we are using a trading chart, we have to make sure that we are giving all open, high, low, close, and volume data. We can also use financial indicator function and apply it to a data in order to generate the time series. This is currently not documented yet, but if you want, we can use it like this. So we just have a financial indicator function. You provide a name of the financial indicator, like it could be anything from here, and then you just apply it to a time series of data, and you will get a three time series for Bollinger Band. And you can, if there is a list of time series objects, then we can use meta information property of that time series to figure out what time series indicates what. And this is the same graph that we can get by using dateless plot. So we can do the same visualization by using dateless plot instead of trading chart. Okay, so I think that concludes my talk. Thank you.